We've started a tutorial series on physics, and in the last class we talked about units and measurement. We measured on the first part, which was units, where we talked about the different types of units on the fundamental, the derived unit, and dimensional analysis, and ended the class by assessing tutorial questions from JAMB. So today we will be advancing to the next section of this topic, which is measurement. Greetings future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host Josh White, and it's my mission to help you crush high school with confidence and clarity. So do well to hit the subscribe button, turn on the notification. Let's get started. We will be dividing this class today in 4 different sections. The first section, we will be talking about length, secondly, time, and thirdly, mass. And at the end of the class, we will be assessing questions from the UTME. Let's begin. Length, being a fundamental quantity, can be measured using different measuring instruments. But before we begin to talk about this instrument, I need to define something very important that we will be coming across subsequently, known as measuring accuracy or reading accuracy. Every instrument has a measuring accuracy. This simply means the least possible measurement that a measuring instrument can accurately measure. So now, coming back to length. Length can be measured using the meter rule for short distance, or the tape for longer distance. Number 2, we have the Vernier Calliper. And number 3, we have the Micrometer Screw Guage. These 3 can be used to measure length. Now the first one, which is the meter rule. Meter rule can be used to measure distance, let's say between 2 points, be it vertical or horizontal. Similar with tape. As I have said earlier, tape is used for longer length measurement. Now, secondly, the measuring accuracy of a meter rule. A meter rule can measure up to 0.1 centimeter or 1 millimeter. This is the measuring or reading accuracy of a meter rule. If you bring out your meter rule, you will notice that it's possible for you to measure, let's say, 5.9 centimeter, 2.8 centimeter, or 20 centimeter. You can be able to measure up to this measuring accuracy. But there is something known as least possible measurement. Now, if 0.1 is the measuring accuracy of the meter rule, it's possible for us to measure the half of the measuring accuracy. We call that the least possible measurement. So that means it's possible for us to measure up to 0.05 centimeter. So that's for meter rule. Secondly, Vernier Calliper. The Vernier Calliper is used to measure the internal or external diameter of cylindrical objects. It is actually made up of 2 scales. We have the main scale and also the vernier scale. The measuring accuracy for a Vernier Calliper is 0.01 centimeter or 0.1 millimeter. That means a Vernier Calliper can be used to measure more accurate length measurements compared to a meter rule, because the smaller the measuring accuracy, the more accurate that measuring instrument can measure. And lastly, we have the micrometer screw gauge. The micrometer screw gauge is used to measure thickness of copper wires or the thickness of paper, which Vernier caliper cannot dare to measure. So the measuring accuracy for micrometer screw gauge is 0.001 centimeter or 0.01 millimeter. So micrometer screw gauge is more accurate in measurement compared to Vernier caliper, and Vernier caliper more accurate in measurement compared to meter rule. So you may see certain questions in UTME, as we will see subsequently, where they will give you a reading and they will ask you to assess which instrument was used to measure this. There is a simple idea to answer such questions. Just check if those readings are written in centimeter. Check the decimal place. If it is 1 decimal place, that must definitely be a meter rule. If it is 2 decimal place, it's a Vernier caliper. If it is 3 decimal place, it's a micrometer screw gauge, if they are in centimeter. So let me show you now how you can be able to take readings on Vernier caliper and micrometer screw gauge. So let's start with Vernier caliper. Okay, this is a similitude of the setup of a Vernier caliper or scale reading. So now, if you notice something from this diagram, this little scale here is known as our Vernier scale. This is a Vernier scale that moves on another scale, which is known as our main scale. So one thing you need to take note is, when you are reading with a Vernier caliper, notice the point of interception and the point of coincidence. Now, if you look at this diagram carefully, you will notice that the Vernier scale intercepts the main scale at this junction. And in the calibrations, there is a coincidence. That means the reading of the main scale coincides with the reading of the Vernier scale at this junction here. So these are two important junctions you should take note whenever you are trying to take readings on Vernier caliper. So now, if we notice this, there are 10 calibrations for each centimeter. So if here is 4, that means this line must be 3.5. So this is 3.5, 3.6, 3.7. Then the Vernier scale intercepted. That means our main scale reading is what? Is 3.7 centimeter. You see it? Now, what you need to take note for our Vernier scale reading is the point of coincidence, as I have earlier mentioned. So we take the reading on 0.01. So let's go. 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08 is the point of what? Coincidence. So our Vernier scale is 0.08 centimeter or 0.8 millimeter. So the next thing you do is, the reading now for our Vernier caliper is the sum of our main scale with that of our Vernier scale. That's 3.7 centimeter plus 0.08 centimeter. Our answer will give us a 3.78 centimeter. That's just it. As simple as that. If you take note, our answer is giving us a 2 decimal place. You can't take this kind of reading using a meter rule. So all you need to take note is the point of what? Intersection of the Vernier scale on the main scale, and secondly, the point of coincidence between both scales. Now, let me show you how to take readings on the micrometer screw gauge. Okay, as we rightly said before, whenever we desire to measure the thickness of a material where certain level of accuracy is demanded, where the Vernier Calliper can't afford, we opt for this instrument called the Micrometer Screw Guage. Like you want to measure the thickness of a paper, or the thickness of a ball bearing object, or the thickness of a wire, we use the Micrometer Screw Guage because of its level of reading accuracy. So, in taking readings using a Micrometer Screw Guage, as we did for Vernier Calliper, you sum the reading for the main scale with that for the reading of the thimble or Vernier scale. So, now this is one thing to take note. If the Micrometer Screw Guage you are using or you are being given has 50 divisions in the thimble scale, all is still the same. That means the pitch will be 0.5 millimeter. So the least count will still be the same, which is 0.01. You see, the least count is gotten by dividing the pitch all over the number of divisions. If we are using a 50 division micrometer screw gauge, that means our pitch is 0.5 millimeter divided by 50. This will give us 0.01 millimeter. And if the micrometer screw gauge we are using has 100 divisions, it means that our pitch is 1 millimeter divided by 100, which will still give us the same least count of 0.01 millimeter. Now this is the way you measure. The top readings is 1 millimeter, whereas the down readings is 0.5 millimeter. Now let's do it. This is 1, 1.5, 2, 2.5, 3, 3.5, 4. It stops at 4 millimeter. So our main scale is equivalent to 4 millimeter, or I'll just say 4.0 millimeter. Then our thimble of Vernier scale. Now, what you check, like we did in Vernier Calliper, check the coincidence, as you can see right here. There is a coincidence between this and that of the thimble scale. So check what is that. Is our 10, 15, 16, 17, 18, 19, 20. It is 21. That means it's 21. Then we will multiply the 21 by 0.01 or simply divide it by 100. That will give us our Vernier scale of 0.21 millimeter. You see, our total is to sum the main scale with that of the thimble or Vernier scale. That's 4 millimeter plus 0.21 millimeter. That will give us the 4.21 millimeter. If you take note, when we're talking about the measuring accuracy, 2 decimal places in millimeter or 0.421 in centimeter. So that's just all you need. Identify the main scale. The up is 1 millimeter, the down is 0.5 millimeter. Then whatever you get in your main scale, add this with that of the Vernier scale you've gotten by the point of coincidence, dividing it by 100. So sum it, you will get your final reading in micrometer screw gauge. Now let's move to the next part, which is time. Our natural unit for the measurement of time is our solar day. We follow a 24 hours day clock, the day and the night. And we know that 1 minute is equivalent to 60 seconds. 60 minutes is equivalent to 1 hour and 24 hours is equivalent to a solar day. So the instrument used in the measurement of time, we use the stopwatch or clock. Most times in our laboratory, this is the kind of one we use, and it has a measuring of accuracy of around 0.1 seconds. Time can also be measured using a sand clock or water clock. These two are most times used in the old time. We also have the pendulum clock, which uses the pendulum bulb. We also have the heart. Our heart also can be used. You know, an average heartbeat is around 72 beats per minute. Yes, so our heart can also be used as a measurement for time. So this instrument can be used to measure time. And lastly, we're talking about mass. You see, most times this quantity called mass is confused or mistaken by many students to another quantity called weight. Like in the definition of matter, some students still define matter as anything that has weight and occupies space, not knowing that that actually is obsolete, is old and no longer in use. It's wrong. The accurate definition for matter is anything that has mass and can occupy space. Now, what is the difference between these two quantities, mass and weight? Number one, mass is measured in kilograms, whereas weight, which is a force, is measured in Newton. Secondly, mass is defined as the quantity of matter contained in a body. That's why matter is defined related to mass. So the quantity of matter a body contains speaks of its mass, whereas weight is the influence of gravitational force on our body. Weight is mass multiplied by the gravitational influence on the body. Thirdly, mass is a scalar quantity, whereas weight is a vector quantity. Mass doesn't tell you about direction, it only gives you the information about quantity, about number, whereas weight tells you both number and direction. Number 4, mass does not change. It's constant everywhere in the universe, whereas weight varies. This is because of the differences in gravity in different parts of the universe. For instance, the acceleration due to gravity in the moon differs from that in the earth. And even within the earth, people close to polar region and people close to the equatorial region have different gravity. So the weight changes. Let's say someone even in an elevator. If the elevator is going up against the gravitational direction, the person's weight is more than his normal weight. And if the elevator, the lift is going down, the person's weight is lower than his actual weight because of his moving in line with the Earth's gravitational force. So weight changes, but mass remains constant. And lastly, in terms of measurement, mass is measured using a beam balance or a chemical balance, whereas weight is measured using a spring balance. So you see, future rockstars, they are not the same, they are different, but many times misinterpreted or confused among students. Please, can we now go and cross JAMB questions? Come with me. Look at this question. To determine the weight of an object, you could A. Use a beam balance, B. Use a spring balance, C. Find the force necessary to give it a certain acceleration, D. Use none of these methods, E. Use any of these methods. This one is very cheap. We just answered it not long. To measure the weight, you need the instrument known as what? Spring balance. To the next question. What is the least possible error in using a rule graduated in centimeter? That's the meter rule. What they are asking you is, what they mean by least possible error is another word of saying the measuring or reading accuracy. The answer is 0.1 centimeter. Measuring accuracy of a meter rule is 0.1 centimeter or 1 millimeter. To the next question. An instrument whose accuracy is 0.05 centimeter is the dash: A. Meter rule, B. Vernier Calliper, C. Micrometer Screw Guage, and D. Lever balance. Now, in this question, we must take note that this term is written accuracy, because most students may think it's meter rule. Please take note, from what I said previously, it's not that the measuring accuracy of a meter rule is 0.05. It's by uncertainty, knowing that between the measuring accuracy of a meter rule, which is 0.1, let's say we have 1.1 and 1.2, we can, by uncertainty, say the mid will be 1.15, which is the difference of 0.05. But that's not the measuring accuracy of a meter rule, because that's not perfectly correct. But it's feasible by uncertainty to measure it with a meter rule. But in terms of accuracy, let's go back to what we said. A meter rule, the accuracy is 0.1 centimeter. Vernier Calliper is 0.01 centimeter, and Micrometer Screw Guage is 0.001 centimeter. So this is 2 decimal place. So the most accurate answer is Vernier Calliper. Please take note. But it's possible to measure that by uncertainty using a meter rule. But by accuracy, our answer is what? Vernier Calliper. Because this is 2 decimal place and it goes with the 2 decimal place layout for Vernier Calliper. Next question. The length of a piece of glass block was measured by means of a Vernier Calliper as shown above. The length of the glass block is, so this is the Vernier Calliper scale reading, and from what we did in our previous class, I told you the first thing to do, know the point of intersection of the Vernier scale to the main scale, which is this point here. Secondly, identify the point of coincidence between both scales. If you notice, there is a coincidence between the Vernier scale and the main scale reading at this junction. So let's take our reading now. So our main scale reading, so this is 0.5, this is 1, it is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, then our Vernier scale intercepted. So that means our main scale reading is what? 1.6 centimeter. Then next is our Vernier scale reading. Now let's count in 0.01 to the point of what? Coincidence. 0.01, 0.02, 0.03, now 0.0 4 centimeter, there was what? A coincidence. That means our Vernier scale is 0.04 centimeter. So then what will our reading be? Sum the both, which is 0.6 centimeter plus 0.04 centimeter. It will give you 1.64 centimeter. So what's our answer? Our answer is what? B. You see it? Now let's take one more question. And finally, we have a diagram, a setup for the reading of a micrometer screw gauge. From the diagram above, the measuring accuracy of the micrometer screw gauge is, what they are asking you in essence is, what is the measurement of this setup? Remember I said to you, we have two scales here. We have the main scale and we have our what? Our Vernier scale. So, and I also said the upper calibrations are measured in 1 millimeter, whereas the lower ones are measured in 0.5 millimeter. So let's count our main scale reading now. 1, 1.5, 2, 2.5, 3, 3.5, 4. 4. So our main scale reading is 4.0 millimeter. Now let's go to assess the Vernier or thimble scale. So also we check for the point of intersection between the main scale and the Vernier scale. Now let's go. It is 10, it is 15. If you notice, there is an intersection between the 16th line. So that means it's at the 16th division. And I told you previously to get the symbol of Vernier scale divided by what? 100. So 16 divided by 100 will give us a Vernier scale of what? 0.16 millimeter. So our reading will be what? 4 millimeter plus 0.16 millimeter. That will give us a 4.16 millimeter as our reading, as our measuring accuracy of this micrometer screw gauge. So our answer is what? D. If you truly enjoyed this class and you have learned something from those minutes we've spent on measurement, please don't just go. Hit the subscribe button. It does not bite. Comment on the comment section. Turn on the notification so you can receive more updates of our content. Like. In the next class, we will be treating equations of motion and projectile. You can't afford to miss that class. I remain your host, Josh White, leaving to catch you another day. Shalom.